Good morning, everyone, or good afternoon, depending on where you are in the United States, Canada, or anywhere across the world. I'm Kaylin. I am the Event and Trade Show Specialist with MetalCon, and I'm here to be your host for the day. Today is a very special presentation. It is being co-presented by the FMA. It's regarding justifying roll forming versus other processes. And it is being presented today by one of their amazing members, Brian Rogers, the Senior Application Engineer of FormTech. Coming up on our next MetalCon Live happening in mid-September, it is Debunking the Corporate Myth, Empowering Middle Management. This is being presented by Philip Thompson. And if you have any young leaders in your organizations, or if you are a future leader yourself, please join that webinar. We hope to see you there. And we also hope to see you at MetalCon this October. Registration, of course, is open for MetalCon. And this year, we are very excited to be presenting multiple different courses regarding roll forming and some very special courses I'll talk about in just a few seconds that are being presented by the FMA specifically. Please be sure to register now, as pricing will be rising in the near future. FMA is presenting two separate workshops at MetalCon this year, Roll Forming for the Metal Construction Industry Part 1 and Roll Forming for the Metal Construction Industry Part 2. Now, one very special thing I will mention is that Brian Rogers is speaking on both of these sessions. So consider this a very brief introduction to what you can learn at these two fantastic 4-hour workshops at MetalCon this year, happening on Wednesday and Thursday. Feel free to contact FMA for additional information or just register online at metalcon.com/register. We'll be happy to get you registered for that presentation. And for additional information on what will be covered in those courses, go to metalcon.com/education. Please submit your questions either through the Zoom Q&A section or in the Zoom chat box. I will be monitoring all those. And based on the questions asked, I'll be sure to read them out to Brian so he can answer those for us. And as always, please fill out the survey at the end of this course so you can be sure to receive your certificate of attendance as well as your credits for the AIA if you need them. And I am going to hand this over to Brian now. Brian, please feel free to take it away.
All right, thank you. Good afternoon, everybody. Like I said, I will be talking to you about why you would be using a roll forming process instead of another one of the metal forming processes. During this, if you guys have a question, please stop me. I'm used to doing this more in person, so I usually can read the room, so this is a little bit different. But when you have a question, I would rather you stop and ask it then, and that way we can talk about it, because at the end of the day, answering your questions is why you're here, and that's why I'm here. And I put this presentation together thinking this is what you guys all want to hear. And at the end of it, my goal is to hit your expectations. So like I said, feel free to stop me at any time and ask some questions. And if we do start running out of time, they usually tell me and we can kind of scoot through the end. And but the main goal is to get your questions answered. All right. So. All right. I think everybody can see my screen.
Brian, you're just going to have to reshare your screen, so click that green button.
All right. Oh, there's.
Brian, are you seeing that screen share button in green at the bottom of your Zoom screen? Oh, I'm so sorry, Brian. I can't hear you.
There, can you hear me now?
I can hear you, yes.
Yeah, I lost the Zoom screen for some reason.
Okay. If you go down to the bottom of your Windows, or at the top, based on if you are using a Mac or a PC.
Yeah.
There's gonna be a blue circle that says Zoom in the middle of it.
Yep.
Go ahead and click that.
Yep.
Should pop up the screen. Do you see me, or do you see the MetalCon Live image anywhere on there?
Yes.
Okay, so if you see the MetalCon Live image, just below that, you're gonna see a little bar, one that says mute, one that says start video, participants, Q&A. And there's gonna be a green box that says share screen. Do you see
Yeah.
that? Go
All
ahead.
I have is like a little thumbnail.
Yeah, do you see that by any chance though?
No, it's not. Ask to start video. Change
Okay.
panel. I don't know what I did.
It's okay. Okay,
Sorry, everybody.
you're okay. We're good. We're here with you. Okay, so describe for me what you're seeing at the bottom of your screen, just so I can help you figure this out.
Well, at the bottom, it's just like regular icons, but up in the corner, it gives me a mute, ask to start video, chat, pin, and change panel appearance.
Okay, and what shows at the bottom?
Just a Zoom.
Just the Zoom. Okay.
Yeah.
So up in that, there should be somewhere that has 3 dots that might say more. Do you see that anywhere? And it
No,
should.
and then another screen comes up, says enter your email, USO web Zoom US. It's like when I click on that, it says you want to exit the video,
No.
but I
Yeah,
can't
so
see it.
just minimize that. That's something that Zoom always does, unfortunately.
Okay.
So how did you share your screen earlier when we were running our test?
I hit that box like you said.
Yeah. Okay. So up in the right-hand corner, you might be able to see something that says view. And there should be something that says recording as well. Do you see that box that says recording or anything that says view on your screen?
No, like all I have is my desktop and then a very small thing that says MetalCon Live. It says ask to start video.
Okay, so go ahead and click on that and let's see what happens.
I just did.
Okay.
Okay, I can barely, yeah, there, I can see you.
Yep, so that's what that button did. So what we're gonna do is I'm going to, do you have the presentation that you can share with me and I can share the screen?
How do I do that? Like,
Email it to me and we'll get it going from there.
okay. Fine. Is this gonna play the video though? That's a problem, isn't it?
Okay, that might be something we'll have to address. But you know what, Brian, what I'm gonna have you do, I'm gonna have you exit out and rejoin the webinar. I'm so sorry, everybody. We are having some
Okay.
technical issues. We
All
will
right.
be right back with you, I promise, and we'll still get you your hours-long education. So
All right.
Brian, go ahead and just leave the entire meeting and hop
Okay.
right back in.
All right.
Okay, we'll see you in a few seconds.
Yep.
Hi, everyone. Again, I'm so sorry we are having this technical issue. Brian will be joining us momentarily, and we will get this webinar started. Again, I sincerely apologize for this delay, but we will be getting going in just a moment. Okay, welcome back, Brian. Do you see anything that has changed on your screen?
All right. Yes, I have like what we had earlier.
Perfect.
A share screen.
There you go.
Okay. All right. Do you see my desktop?
No, not yet. So you're going to have to click that share screen button. It's going to open up to a window and go ahead and select whichever screen you would like to share.
Said host disable the
Oh,
participants.
sorry. That's because you rejoined. Okay. Go ahead and try that again. Fantastic. I'm seeing your desktop screen.
All right. Now let me start up my presentation again. You just see a blue screen right now, right?
That is correct.
Yeah, I got it on the wrong screen.
Oh, no.
Should be able to stop sharing and then reshare, right?
Yes, we should be able to.
Or
So feel free to.
there. Now,
There we go. Perfect.
great.
Awesome. Okay, thank you everyone for your patience. Go ahead, Brian. Thanks again.
All right. Well, sorry about that. Just like roll forming, nothing ever goes right. So we'll get going. So as I was saying, we're going to talk about justifying the roll forming process compared to other processes. So here's some highlights we're going to talk about. We're going to talk about what roll forming is. I'm sitting in southern Indiana, and in this area, some people actually think roll forming is making pizza pockets at the Pillsbury plant over in Kentucky. Other places, people think of roll forming as being, big 3-roll benders instead of the forming process that we're going to talk about. We're going to talk about where roll forming is used. Wherever you're sitting, more than likely there's a roll form product there, or you drove in something that had a roll form product. Walk by, you'd be amazed of how much roll forming is used. We're going to understand why the roll forming process has the ability to have value added possibilities of how, by adding other processes to the roll forming line or to the roll forming process, you can really add value to your product. So instead of just running a commodity, you can run a product that has a little more engineering into it and a little more processes in it. It may not run as fast, but at the end of the day, it's giving you a complete part without the use of secondary operations or third operations. We're going to talk about the consistency of roll forming, and just at the end, kind of talk about volume requirements of, when it starts to get triggered, that roll forming is probably the better option than the other processes. So as I told you before, when we look at roll forming, the first question is, what is it? Many times, everybody knows what an extrusion is. Everybody knows what press brakes are, and they know what stampings are. Some of us learned it in metal shop. Some of us have just, heard the terminology of being in the industry. But when you bring up the term roll forming, sometimes you'll have people look at each other and they have no idea what roll forming is. They may even have a roll former in their facility, but you don't even know that that's the operation that it is. So when we look at this, we're going to see how roll forming is very similar to these, and then how it's also very different. So the question is, what is roll forming? Basically, roll forming takes a strip of metal and it continuously forms it into a shape. As you see by the little diagram there, the material will pass through rolls or stations. This is done at room temperature, and each one will create a bend, and it'll do it bend after bend after bend until it comes up with the desired cross section. Here, as you can see, each one of these is a pass. On the left would be the roll flour, where you lay every stand on top of each other, and you can see how the metal goes from a flat strip to the finished part. And then on the right, you can see it as it's broken out, and you could go pass by pass and see how it is incrementally formed piece by piece to form the cross section. On these examples, it looks like you're starting on the outside edge first and then going to the center. That's not always the case. A lot of times we will start in the center of the cross section and work our way out. One thing is if you've ever asked yourself, do I have a product that could be roll formed? If you can take a piece of paper and bend that piece of paper to create that, a lot of the times it can be roll formed, because basically what we're doing is we take the shape as the roll flower and we unfold it to make it look like these two examples. Roll forming has different looks. As you can see, one of them is just working the outside edges. This is a lot of times what you'll call a dual head machine or a duplex machine. The rolls are cantilevered, so there's not a shaft that runs completely through from one side to the other. It's usually helps make very wide products. There are times, though, a shaft will run through it all for very wide panels for work that has to be done in different areas of the strip. And then what I call more of the conventional or the normal roll forming, which would be on the right, which is you would have it supported on both sides of the roll tooling. The shaft would run through and you would pass the material through and it would make your shape. And a lot of times these are cross sections that would be probably less than 20 inches wide strip width, but there are certain machines out there that will take a larger strip with shafts that pass all the way through the tooling. So where is roll forming used, as I talked about earlier? Well, here's just some examples. The automotive industry, actually, Carl Yoder, who started the Yoder company, and John Tishkin, who started Tishkin, most of all their machines were in the automotive. They had contracts with Henry Ford and other automotive suppliers in the Detroit area and the Cleveland area, and they produced roll forming products for cars, whether it be running boards or different things like that. The appliance industry uses a ton of roll formers everywhere from water heaters to refrigerators and ranges. There's all different types of parts on these appliances that come off of a roll former. The new buzzword, solar. Solar has been a really great fit for roll forming because it usually needs long parts, and roll forming does very well at producing long parts. The aerospace industry, if you have flown in an airplane, most of the stringers or the ribs of the airplane come off of roll formers. And so, they're used there. Office furniture, if you're sitting in a cubicle, I would say probably 99% chance that your cubicle's post and the interior pieces of your cubicle came off of a roll former. The construction industry, which is a lot of what MetalCon goes towards, your steel studs, furring channels and drywall stuff, that all comes off of roll formers. Seating, when you sit in your car and you adjust your seat forward and back, they're on what we call a seat track. Those come off of roll formers. In the HVAC industry, a lot of the ductwork and different things like that are other pieces of roll forming. So as you can see, it's basically any industry requiring a tailor-made continuous cross-section has the ability to use roll forming. I'm sitting here in my office and I look at the ceiling. The ceiling is a drop ceiling and it's got ceiling tiles. Well, what's holding the tiles up, those are roll formed. So as you can see, it's a huge industry. It touches all different industries. So it's kind of understanding what it is to see if it would work for you. Here is an example of some of that. On the right would be like some 2x8s or 2x10 steel studs. But then on the left, as you can see, these different shapes are all different parts that would come off of a roll form. Kind of give you the spectrum. Yes, when you were a kid and you were running a toy train set, the railroad track, if it looked like this here, it came off of a roll former. But also, as you look over here on the right, if you rode in a subway car today or rode on a train, a lot of the pieces on those rail cars were also produced off of a roll former. So as you can see, it can be very small all the way up to very large products that can come off of it. It's just depending on sizing the machine correctly and knowing what your expectations are. So we're going to talk about some different advantages. basically, roll forming offers many distinct advantages when it's compared to alternative metal forming methods. Most of these come from the ability to accurately process a variety of raw materials. We're going to talk about the different raw materials that can go through a roll former. I hit real quickly on the multiple lengths that you can have the same profile, whether it be, a 4-inch part to, an 80-foot part. And the biggest thing that roll forming loves is high volume. It loves to make a lot of parts. Roll forming has the ability to run critical surfaces, whether it be stainless steel or pre-painted, different materials like that. By the way it forms the process, a lot of times it's able to create the cross section without cracking the coating, and it's able to give you a finished product from, keeping it from going to another operation to either go through a buffing station or painting. The range of roll forming, it can be less than 10 thousandths thick material to right around 1 inch thick. 1 inch is not very common, but 250 thousandths, 300 thousandths is pretty regularly done. Basically, you got to look at your bend radii and understand that. If you're at MetalCon, I do talk about materials, but the biggest thing is can the material withstand the bend that you're putting it in? And if it can, a lot of times roll forming can take care of it for you. It also has the ability to build mild steel, or as you hear like in the automotive industry and more, your HSLAs or your high strength low alloy steels. Getting up into martensite materials and 80 KSI type materials are roll form quite common anymore. So here's just another list of some of the materials, and here's some examples of parts. Aluminum. I've been doing this for 20 plus years, probably pushing 25 years. And every time I've seen the aluminum prices go high, you see a lot of inquiries to start changing their products over to, galvanized steel. And then when aluminum goes down, you'll see it go back the other way. And I'll talk about some of the reason that is later. You can roll form titanium, stainless steel, your commercial grade steels, your high strength low alloy steels, boron. I've actually read an article years ago that somebody had built a roll former and they were running wood panels through it, steamed wood panels to put a bend in it. Now, granted, it was in a very tight bend, but that's what they were doing. I've also seen roll tooling made to roll cardboard. So there's a lot of possibilities with the roll forming process, and I'm not going to tell you I know all of them, because sometimes there's stuff out there that even surprises me. But understanding the process, knowing that whatever you want to bend, that it can withstand the bend, it has a possibility of being able to run through a roll form. So when we're looking at our products, real quick, kind of gut checking, a lot of us know what stamping parts are. Obviously, these stamping parts here, they're not a continuous shape. So, that's kind of the world that they'll always live in. You're not going to do those on a press brake. You're not going to do them on an aluminum extrusion. They pretty much, that's their niche. But now when we move over to a press brake parts, a lot of times begin as press brake, but as the volume goes up, they turn into roll form products. Like this product here that you're seeing, yes, it's short, and depending on what your volume is, it could be roll form. But if you need different lengths, this is a perfect roll form part because it's a continuous uniform shape. And then as we get into the roll form products and you want to start adding value, you look at these parts here, you see that there's holes in them, there's some welds, there's also the ability to marry two different materials together inside the roll forming process to have a tailor welded cross section if your coil is welded with two different thicknesses, or you just bring the two together, and we'll talk about that more later on. So here we're going to talk about stamping. A variety of sheet metal, I'm sorry, a variety of sheet metal forming manufacturing, comes off of a press, whether it's punching holes or blanking, flanging, coining, that's comes off of it. So when we compare the two, here's what happens. Roll forming usually holds the advantage in the length, because if you're only going to stamp a 4-inch part, your die is very small. Let's say though, the part now it's going to go on an automobile and it's going to be for a side door on a minivan. Well, now that press bed's got to be maybe 36 or 48 or 60 inches wide. Well, let's say we want to put a sliding door on the side of a bus. All right. Well, now that press bed's got to go to 80 inches or 120 inches. With roll forming, usually now with the way controllers are, we just go to it and tell it to make an 80-inch part, make a 120-inch part. Maybe we want a 400-inch part. We just tell it to do it, and it can make it very quickly with the same tooling and the same die tooling to produce the part. Where in a stamping die, that die has to grow because it hits one time and then it's done. The tolerancing. Roll forming is very consistent when it comes to the profile. When it's forming the profile from the beginning to the end of the coil, it will hold the tolerance very consistently as long as the material going in isn't fluctuating. It's the old rule, junk in, junk out. So if you're holding a good tolerance with your raw material, chances are you're going to have a very nice, consistent process going through the roll former. Sweeps. I have seen sweeps done, or bending, or putting crown in a part, or bow, however you call it. It can be done in a press. A lot of times it is difficult, but it can be done. Do it all the time in roll forming, as long as it's a continuous sweep. If not, then you have to go into the operations like benders and different things like that. Tooling cost. This is kind of up in the air, but for many sections, roll forming will be a least expensive way to go and will keep your tooling costs down. There are times that the roll forming tooling may be a little more depending on your cross section, but probably 90% of the time for a continuous shape, the roll tooling will be less expensive than the stamping. When it comes to high strength materials, yes, presses, dies, die makers have gotten really good at controlling the high strength materials, but roll forming pretty much came out of the gate being able to hold consistency with high strength materials. And a lot of it is because of the forming process. And I'll show you that more as we go on. But basically, because of the way it folds it up and the way it's moving the metal, it's able to set those bends easier and more consistently. So here, we're not throwing stamping out because a lot of times we will put a stamping operation in front of a roll former. For instance, this part right here will have what I like to call, we'll take a strip and turn it into Swiss cheese. We'll punch a bunch of holes in it. We might have some embosses in it. We might have some flanges. We'll put this in the flat. As you can see, the material has gone through the press and it's coming out and it's getting ready to go to the roll former. So we've put a bunch of a stamping operation in front of the roll former to create the ability to make different cross sections. As you see on the left, you see different roll form products. These all are in one process. So when the part is cut off at the end from a continuous coil, that is a complete part with all those holes in. Here's another way. Instead of just doing it with a press, we have what we call a rotary, where you can put that on. And as you can see, this can run at high rates of speed, but it goes through and it can take and put a continuous hole pattern in the strip before it goes into the roll former. We see this done a lot in the metal building industry on certain products. So now we're going to talk about aluminum extrusions. In the aluminum extrusion process, they take the billet, they heat it up, and then, kind of like pushing bubble gum through the dies, and it creates different profiles. Very very tight profiles, very good profiles, but there's no value add to them. It's just the product. So when we look and we compare them, length, yes, there you can have an aluminum extrusion can make very long parts or very short parts. Tolerancing on the profile, aluminum extrusion hold very tight tolerances on the profile. But when it comes to putting a contour in the part or a sweep, you have to go to another operation to do it, where we can do it in line on a roll former. Tooling cost, as you all know, if you do aluminum extrusions, tooling is usually very inexpensive on an extrusion compared to roll tooling. But when you get to high strength materials, they call it aluminum extrusion for a reason, because that's pretty much the only material that can go through it. Otherwise, the metal that you're pushing through it is the same as the metal that it's going through, and it will destroy the dies. So when you're looking at those processes, that's one of the key things that roll forming is the ability to run different types of material, not just aluminum. So then when we get to press brakes, as you can see as the little video there, that's a perfect roll form part, because as you can see it's just doing it in one hit. The roll former will do it as it's rolling. Press brakes are very good for when you're doing low volume of stuff. But when you get into the higher volume and you want to run at a higher rate of speed, you're usually limited by your strokes, by the number of hits on the profile, and by your expertise of your operator. So when we look at it, roll forming, like I said, we can run a 400-inch part. We can run an 80-foot part. In a press brake, it's how big is your press bed, right? You have a 30-foot long press brake? More than likely not. Tolerancing, because of the way the press brake process is, and you're hitting one and pulling out and going back in, roll forming gets tighter tolerances than press brakes. Now, yes, there are press brakes out there now that come in and hit and will hit and hit until they get it exactly right. But you're losing cycle time, where in roll forming, you're just passing through the rolls and you're getting the same tolerance, but at a higher rate of speed. Sweeps, again, if you're making the profile, you're not putting a contour in the part. You're just making it. With roll forming, we're forming the profile and we have the ability to put the sweep in before the operator even touches the part. Tooling costs, as we all know, press brakes are pretty common, very inexpensive, but how many times do you have to do a tool change to get a part done, depending on what the profile is? Where in roll forming, once you design the rolls and the rolls are on the machine, it's going to make that part all the time. High strength materials can be done by both, yes, but again, you have to play around with setting those hits and getting that radius set coming off of a press brake, where in roll forming, we're passing through the rolls and the way it's forming it and it's bringing it up. Once we have that, it's very repeatable to load the tooling, take the tooling off, put the tooling back on, and achieve that same tolerance and consistency, even with the high strength material. Does anybody have any questions as it's coming to this? Like I said, feel free to stop me, or if I'm running a little fast, let me know. Like I said, this is for you, and I want to make sure you guys are getting what you need. Here, we're just looking at the roll forming process. This part in the center is made on both. It's made on a press brake, and then it's also made on the roll former. As you can see, the footprint of the machines are somewhat similar. But the thing is to make that part that is 1, 2, 3, 4 hits in the roll former, you just turn it on and it could run 100, 200, maybe 300 feet a minute. And when you're running, 1 foot parts or 4 foot parts and you're running 100 foot a minute, that's a lot faster than what your operator can do as they're trying to hit all 4 pieces coming out of your press brake. So you've heard me talk about the consistency of roll forming. And when we're looking at the consistency of roll forming, the reason why is, as you can see, it's coming in. I like to call this the forming V, because if you're standing at the exit end of the roll former and you look down, or if you're standing at the entrance end and you look down through the tooling, this is what you see. The material is coming and it's like making a V to finish the cross section. So it's flat, it's bending its edges, and it comes in, and then you see it starting to lift. And as it's carrying through from station to station to station, it's producing the final product. A lot of times, if you think of a progressive die in stamping, it's hit to hit to hit to hit. But instead of a transfer picking it up or a person picking the part up and moving it to the next station, we're just traveling through. Because instead of our ram, coming up and down and stamping the part, we're rolling. We're just passing through and bending it as we pass through. So when we look at it, the ability to form, a lot of times a profile, a very standard, is plus or minus 30 thousandths of an inch on any dimension on the profile. Can we do tighter than that? Yes. Do we do? Yes, we do it all the time. I've seen plus or minus 20. I've seen plus or minus 15. I've also ran certain products like seat tracks where in certain areas of the cross section, we're holding plus or minus 1 thousandths of an inch. Now, granted, if we're holding that tight in one area of the cross section, we need to have a little wiggle room somewhere else. So we can't just tolerance the whole thing at plus or minus 1. But there are certain areas of a cross section that you can achieve those types of tolerances. This little diagram here, everybody knows, pretty common strut. Well, when you run that type of product on the same set of tooling, all of those heights are actually ran off the same set of tooling. And we're able to hold this plus or minus 30 with a plus or minus 2 degree on the angles. Yeah, all the way from a 875 thousandths tall up to 3 1/4 inch tall part. If you're taking notes, this is pretty good. These are very attainable roll forming profile tolerances. If you're talking fractions, it's plus or minus 1/32. 3+ decimals, plus or minus 15 thousandths. Certain dimensions can be plus or minus 5. Like I said, in certain products, we have gone tighter than that. But you start talking about the material, the profile, the machine, and everything, but it is achievable. Sorry about that. Then on the straightness, usually 1/4 inch and 10 feet. And that is for the crown of the part, the sweep of the part, or when we're talking about twist, when the part comes out and it wants to go clockwise or counterclockwise, we're able to hold those. Have we held tighter than that? Yes. A lot of it depends on your measuring method, and it depends on the product itself. And then cutoff lengths, plus or minus a 64th. I've seen tighter than that also, plus or minus 30 thousandths of an inch. It depends on what your product is. I do a lot of estimating and different things and putting lines together. And my thing is, I need to know what is important to you, because if I sell you a machine that holds plus or minus 30 thousandths of an inch, and you're just measuring it with a tape measure and you don't care if it's within a 1/2 inch, I could end up selling you the wrong type of machine that will hold that tight tolerance when you don't need that. And we can focus on what you're really needing. So when we are talking about the consistency, we really look at the roll design. And when we're looking at the roll design, we're trying to make sure that we're holding that consistency and we're eliminating things like flare. What flare is at the end of a part when it's cut off, because of the forming process, it has residual stresses. So when you release it, it wants to spring open a little bit on the exit side of the part, or it wants to toe in on the entrance side. And the reason for that is, as it's going through the tooling, it's being knocked in. So that's where you get the toe in on the leading. And on the exit, it's allowed to release. So it wants to flare out. Flare can be controlled, but it will never be eliminated. If anybody can eliminate flare, they need to patent it, and they will be a very wealthy person. But here's some of the ways that they do it. On this product here, they're doing a channel, and they're doing it in 10 passes. That's what those numbers mean in the diagram. But as you can see, it's supposed to be up and straight, like on pass 9, it's actually complete. But on 10, they're actually overbending it. And the reason why they're doing that is so when it comes out and it releases, it stays. And that bend number 1 will stay at 90 degrees and give you a nice straight cross section, or a straight leg, to stay within that plus or minus, 2-degree tolerance. Here's our twist. Our twist tolerances, basically 120 thousandths in 40 inches. Another way to say it from the one I was talking about earlier. And like I said, that is take a 40-inch part, you hold it down on 2 points on one end, you look at the other, and the corkscrew effect of it will be within that 120 thousandths of an inch. Can you do better? Yes, it's done better all the time. It really depends on your material, and do you have the machine size right, and is the tooling correct? Camber or sweep or down bow, everybody has different terminology for it, but it's 40 thousandths in 40 inches, and bow is 40 thousandths in 40 inches. Here's a picture of this is an appliance part. It's actually going through a roller straightener, and it's a dual head, so there's a set of rolls on both sides. And this one here is able to hold a very consistent part. I do believe we're holding 10 thousandths of an inch in 40 inches on this, but it's going into a automatic bender, so it has to be very consistent so the robot can pick the part up, carry it over, and put it in the bending operation for the final product. Just a note, if you are looking at having a roll former, or you have a roll forming process and you want to add automation, which is kind of the big buzz anymore because of labor shortages, make sure the tolerances of the machine that's supplying that match what the automation needs. I've walked into a lot of different areas where the products are going to robotic welders or like for here, benders, and the tolerance was great for 15 years, but there was variation that nobody saw because the person who was doing it before would just manipulate the part a little bit where your automation can't. Just a little side note, make sure that the tolerances coming off of this operation will agree with the tolerance expectations of the next process. Here's just another way that we can sweep a part off. This part here is an automotive part. It goes in the door of a vehicle. And it is basically, as you can see here, it is a 3-roll bender coming off of a roll former, and it will put an arc in the part. But we also have the ability to adjust twist, and we also have the ability to sweep it left or right. A lot of times in the automotive industry, it is not just a straight bend. It's like a helix. We want it to twist. We want it to go left, right, all over to follow the contour of the car. So to do that, we put units on there like this. So as the part profile is produced by the roll form tooling, and then it goes right into this operation, we're able to manipulate that part to either go left or right, up or down, or even to come out on purposely helix or twist to follow wherever it's going to go. Drum rings, if you think about in your plan, if you get stuff that comes in the drum rings, those come off of roll formers and sweep units. Bicycle tire rims, motorcycle tire rims and stuff, those all come off of roll formers. They come off, and then I don't have an example of it. They go through what we call a shoe, is what we dub it, and it comes in and it makes the circle, and you cut it, and then a lot of times the rim comes down and the operator just butt welds the rim after it's cut. So you have one operator who is taking the material from a coiled flat, coming in and then making a finished product. And it's one operator going through all those operations because they're all tied together. Here's just more examples of different size parts. As you can see, one of these is a sorry, my mind went blank, but like sheet metal that would go on the side of a building coming through. It's a very wide roll former. It's going through, it comes through the machine. It puts the ribs in the part, it's pre-painted. And when it comes out the other end, now this could be from a continuous coil, or you could feed blanks into it. Roll forming is not tied to one or the other. It will do both. The one thing I will tell you is if you are going to blank feed a roll former, you will want to make sure that your minimum length is 3 times the horizontal distance. And I don't talk a whole lot about that here, but I will at MetalCon, where that measurement comes from. But there are tons of products that come through a roll former from blanks, not from continuous coil. Why? A lot of times you don't have to buy the extra presses, and you don't have the volume for it, or you don't have the room, and you just run your blanks through, and you're very happy with the product. The other picture here, this is a seat track, and what you're seeing there, and I'm going to kind of look in here, the ball bearing will run on the inside and the ball bearing will run on the outside. And this area here, a lot of times is at plus or minus 1/1000th or 2,007-inch tolerance. And as you can see, the material is important because your material is a part of that tolerance thing. So if your material is varying by 6,000ths, it's really hard to hold plus or minus 1. But this comes off very consistently because when it comes together, they want to make sure that when a 105-pound person who's going to move the seat forward and back on a car can do it with the same amount of effort as a person who is 6'5", 295. So it's very important that that part of that cross section is held that way. So that way, when they put these pieces together and the ball bearing, that the efforts are within the allowable tolerance. Here is just another example of different sweeps that come off of the part. As you can see, this is an automotive cross section. It's really hard, but it actually is bending in multiple directions. So it's got a helix in it. This is a part here that would come off one of those shoes. You can see how tight the diameter is. And some of these other parts have a small crown in them, and or could just be straight, just to show you what can come off of a roll former. I used to work in the automotive industry for a while, and we would go from product line to product line and use the same cross section, but we would put a different, they called it cord, but it's basically a different sweep in the part. So one might be more gradual, one might be sharper, depending on the vehicle that it went on. And we would just change that with the sweep unit, kind of like I showed you, and we wouldn't even change the tooling. So we were able to change over very quickly, utilize the rolls, and make the same cross section, but completely look different when it came off the line. When I talked about the flare, this machine here is an anti-flare device. And what that does is it kind of helps set the end of a profile. When it cuts off, it does flare out beyond the tolerance. We're able to monitor it and set it automatically here on this type of machine. There's a lot of different ways to take care of flare. You don't have to be as elaborate as this. We can put different things in the tooling, different side stands or different side rolls to help work with the roll tooling to eliminate flare. And these are just some examples that I wanted to show you. Here is an example of a blank fed line. It's one of those dual head or duplex machines that I was telling you. And another one is a continuous coil going through multiple operations. So we're going to talk about the one on the left here, the dual head machine. And a lot of times these are used when you're doing different size panels, and all you want to do is form the outside edges. So what you can do is if you have a 24-inch wide sheet and you want to form just the edges, you can go ahead and put that profile that you want on each edge. But then let's say your next product line is 36 inches wide. you just move the roll former will index out and it'll allow for that longer strip and it'll put the exact same profile on the side. It can be automatically blank fed from something putting it on the rollers and it'd be automatically fed in, or your operator could hand feed them in. I've seen this done multiple different ways in multiple different industries. Again, it can do pre-painted materials, stainless steel materials, regular mild steel, high strength steel. They all come through. It's the same forming process. It's just that you are forming on each side. An example of this is a vending machine for soft drinks. That wrap around it more than likely came off of a roll former. It came off of a roll former. It put the profile on the edges, and then it goes to another operation called a wing bender, and then it makes like the shell that drops over top of it, which covers and makes it look the way it does. Also refrigerators. The one we see on the right, this is a continuous coiled machine with a pre-notch operation or a pre-punching. So we put a stamping operation in line. So it comes off the coil. It's going through a straightener. And when it comes out of the straightener, it goes into the press. The press will put whatever features that is desired for the product. And then it'll go into the roll former. The roll former then will create the profile, and then it'll be cut off. Here is a little different example of that blank sled line. This line here actually is taking sheet of steel, putting it on. The roll former is back here, if you can see my mouse. It's coming through, it's bending the edges, and then it comes into another operation where it is actually forming the exit and the entrance end. These blanks are coming in from a stamping operation with the embosses in it. As you can probably tell, this is a door. So this roll former is able to run all the different door families by putting the profile on the edges, and then this other operation is putting the features on the end of the part, which therefore one operator and it's a part complete when it comes off in the savings, because you're adding all that value into the process. It's not just a roll former, it's a stacking operation, it's a roll forming operation, and it's a press operation. This is those seat tracks I was talking to you about. As you can see, there are actually 3 roll form cross sections here that are together. There's the outer, the intermediate, and then the center channel. And this machine here, let's see, it's supposed to move it back up. I was supposed to play larger for you all to see. But we can watch it. It goes through. You have a cutoff operation. This is what we call a post notch. So we actually are punching the part with 2 different presses on the exit end. And then as we're going through, you can see that the part was being manufactured from the roll former and a continuous coil. On this machine, it ran all 3 cross sections. We call these rafts that are sitting here on the floor. And these rafts would come in exchange with these to run the 3 different profiles. It just so happens on this one, we're not using the beginning of the roll former. So we're just running the coil over top, and then we're dropping the coil down into the forming stations here at the split of the roll former. And then as you can see, you see the strip, you see the tooling, and then the part is going through, it's being formed. It comes into a straightening process, and then it comes into the presses. And on this part, there are actually 3 presses at the end of the line that are in line being used to produce those parts. So this press here would be doing 1 set of holes. There's a small press here, and then there is a cutoff operation. Here is another one that the pre-notch operation. Hopefully the video plays. There we go. This here is making a repeating pattern. this is at a slow rate of speed, but in actual reality, this line is pushing almost 200 feet a minute. It puts these holes in, it comes through. Trying to give you a better shot. You can see the stamping operation and the hole pattern that it's giving, and it has a set distance between each hole to the part print, and then it will go into the roll former. This other machine here on the right, this is another post notch operation where it is coming out of the roll former and some type of feature is being put in, and then the cutoff operation is happening next. This is a simple roll former. It's just a continuous coil. It's coming off the coil, running through the roll forming machine. It's coming through a straightening device, which this would be an Amco block. And then it comes through and it comes into the cutoff press. Once the desired length is hit, whether it be by a flag style like it was back in the 80s and the 90s, or today with controllers, we use encoders and electronic counting, and it knows when to cut the part. It cuts the part, the die moves forward during the cut, and then after the cut is complete, it goes back to home and it's ready. These machines, this here was a slow example, but 100 feet a minute is very common, all the way up to, there are actually machines that run over 500 feet a minute. This is another one showing different stamping operations. Like I said, we're coming off of a reel. We're coming through a straightener to take any camber or any coil set out of the coil. It's coming through with the different press technology. We put different holes in. We can set the holes at different distances apart for different part lengths or different features in different areas of the part. It comes in. Here's just the example showing this part is 72 inches long being ran, comes through, it goes through each one of the forming passes. As you can see on here, the edge of the material is actually taken away. So we started forming it in the middle and we started breaking it up. So all those features are in the part. And as it's coming through, it's bringing it up. There's one of those side passes I talked about earlier to help make sure that those legs are made correctly. And then we come into the cutoff operation where it will line up and it will cut through that feature, and it'll make sure that the part has the feature that's desired on the end of the part and on the exit end of the part in the correct spot. As you can see, the roll former is, its footprint is the same, but the part lengths could be, 72 inches long, it could be 112, or it could be 36 inches long. It's just a matter of what we set the length at to do that. Not only presses, we also have the ability, whoops, back that up. This is a cantilevered machine. This machine actually has the ability to have 4 sets of tools on it, but it actually is running a flying saw. It's not even a die. It is a saw that is sawing the part. This part here is in the window industry, and it's doing a small aluminum part, and it's actually sawing the part off instead of cutting it with like a guillotine or a slug or a crop cut operation. Then we get into some of these, like this machine here is a more automated machine. It runs at a high rate of speed, and it runs a lot of the metal building industry parts, like your 2x4s and 2x6s and 2x8s. Basically, it takes one operator, or sometimes it can run, if everything has a stacking system, it doesn't even need an operator. It just needs somebody to monitor it. And as you can see, it has the ability to index in and out. There's that flare unit that we were talking about on the end. The material goes through. As you can see, it put embosses in the edges of the product in line, and it's forming the part. It's putting holes in the part. and it's able to make your part complete with the different web sizes. These machines here run between 300 and 500 feet a minute. A lot of times these parts are commodities, so running fast is very important to the end user to be able to make a lot of product in a short amount of time. We talk more about value add, what you can do. This part here is not only is roll forming, but it's also adding a vinyl strip to the cross section. This is a damper blade in the HVAC industry. So it's like a seal on the louver. So when the fan comes on and the louvers open up, but when it closes, it has a seal on it. And we're installing the seal into the cross section and crimping it. So that way it's complete. And they just need to install it into the framing of the louver, or the louvers framing, so that way it's all complete and they don't have to try to attach the seal. The seal is being done in line. Back when I was younger, if anybody remembers riding in the old pickup trucks or different things like that, when you rolled your window up and down, you had that black flocking, we called it, or fuzz in there. That came off of a roll former, that window channel, and we would actually put glue on that material and then put that and incorporate it in the roll former. And then when we cut it off, that window channel was cut with the flocking already in it. So we were adding that flocking to it during the roll forming process. There's many other things that can be done in the roll forming process. You could put stamping operations in the middle. And different things like that. It's just, what your part is, and then how much can we do in line to add value to the end product. You can weld. Here's just a laser weld part. It's kind of a neat video, but this is a roll former, tube former. It's coming through, and it's actually making stainless steel tubes for handrails. As it's coming through the line, it will be, the edge of the material will be conditioned by brushes. As you can see there, it's being prepared for the welding operation. It will go through the forming operation to create the round section or the tube. On this particular one, it could be different shapes. It will go into, this is a laser welder. The laser welder will, join the two edges together. This is a sanding operation where it's sanding the weld in line still. And then after it leaves the sander, it is going through what we call a calibration mill. The mill is resizing it, making sure it's to spec. And then when it comes off, it is being cut off by a saw, actually. And then it is going to the next operation, which is a deburr operation, where it is going and both ends of the part are being deburred. So there is no burrs on the part. Just another example of where roll forming is used and how different processes are added to the roll forming process to create a higher valued product. Here's just I just kind of threw this in here to let you guys kind of understand the whole world of roll forming. These are rotary spot welders. And these are basically another welding operation that can be added into your roll former if you wanted to have welded parts. And then this is a high frequency, which would allow you to run very fast. These are step beams that you see in the pallet racking industry, but there's these types of, I call them, they're custom profiles for whatever your needs are, and tubes. You think of your fork trucks, your high-lows, the rollover bars come off of roll formers, tractor cabs, combine cabs, frame rails on semi trucks, framing in different frame rail pieces and automobiles. They're all with these different welding products, and they come off of roll formers. There's also TIG welding. TIG welding is kind of phasing out because it's not allowed for a whole lot of speed, but it is still being used and you can have that. Is there a question?
We don't have a question, but we are running out of time.
Okay, I'm finishing up. I've got about maybe 4 more slides.
Perfect.
So when we were talking about the roll forming, I wanted to talk about some of the advantages of it, because I know right now in the roll forming industry, or not the, but in the manufacturing industry, we are short of labor. So we have these things here to be able to set the roll tooling. We have what we call single point adjusters, where you are setting to a number instead of using the old feeler gauges and different things like that. Or you can also, as we were shown, this is a drywall framing machine that it will automatically go by a push of a button, and it will set and run all your different sizes. Or you can hand crank it, as you're seeing him taking it in and out for different widths, whether it be an inch or 8 inches wide. And then you can either have a flange or take the flange off. And as you can see, makes parts in a very fast rate. What's unique about this machine is it actually is a coil fed, blank fed line, because the shear is actually before the roll former. And we're also putting inkjet spray and labeling every part that's coming off the machine. Okay, I'm going to go ahead and just exit this one and go to the next one. Here is a machine that instead of those single points, you actually will go and load your program, and your program will have all the settings. Your operators will bring up that recipe. They will type it. They will tell it to set. It will go ahead. And once it goes, it will go ahead and load the mill. It will load those settings and set the roll tooling automatically to everyone. And it is done in a matter of seconds. I'm watching my time. I'm hoping you can see it happen here. He's going to go ahead and advance it. And as you can see, they are automatically being set to the proper tooling setting. So here we say that many press brake parts are converted to roll forming, and the reason why is volume requirements. So basically, roll forming output is continuous. A lot of times you only need one operator. We like to set our lines in the automotive industry, a lot of them are around 50 feet a minute, but in different industries, 100 foot a minute is the standard, all the way up to your 300 and 400 feet a minute. And we usually like to see volume size in linear feet of 10,000 linear feet to over 1 million linear feet. Basically 75,000 pieces a year. And then here's the big one, the last slide, is when you're looking at the same product running off of a press brake compared to a roll former, a lot of times 20 to 80% is labor costs in a press brake, where usually 3 to 15% is your labor cost in a roll former. And your end piece price is between 60 and 90% material content, or your cost of your material, where in a press brake, it can be as low as 20 or 50%. So that is a big economical advantage to roll forming, is you're able to make a lot of parts in a fast amount of time with a small amount of labor. All right.
For everyone on this, for everyone on this call, please take note of the slide on the screen currently. If you do have any questions about roll forming or its benefits and challenges as compared to other processes, please reach out to Brian. Brian's information is on the screen right there. The other thing you can do is you can reach out to the FMA as well. The FMA is very willing and has a lot of information to share with you. I want to personally thank Brian for joining us today and for offering his insight and expertise in these topics. I also want to remind everyone that if you liked this topic and if you want to see Brian in person, he will be speaking at MetalCon this year. He'll be doing the 2 workshops taking place on both Wednesday and on Thursday. So I also want to thank everyone here for joining us today. We so appreciate you and we appreciate your time. We hope to see you at a future MetalCon Live. Again, Brian, thank you so much for your time. We look forward to seeing you in October, just a few short weeks away.
Thank you.
Thanks, everybody. We'll see you soon. Bye.